Hello there fellows, welcome to our new video. In this video we are going to talk about the robot design part in Fusion 360. And in there we are going to design a robot in Fusion 360 which is a differential drive robot, and then we are going to talk about the robot design criteria, and then we are going to talk about the joints and inertia of the body, and also we are going to talk about how to convert a Fusion 360 file into a URDF file, which is a Universal Robot Description file. Firstly, we need to install the Fusion2URDF repository in our computer. This repository allows us to convert our Fusion 360 files into Universal Robot Description file. And in there, you can git clone this link, or you can download it by a zip file. And then you have to go to the path of this repository which you installed on your computer, and then you have to write this line to your Windows PowerShell, and by doing that you can use this repository in your Fusion 360. Now let's start drawing our robot, but before that we have to change some settings of the Fusion 360. So in the preferences part, as you can see, the default modeling orientation, it's actually Y in default if you install the Fusion 360 for the first time. And in there, you need to change this to the Z-axis up. So by doing that, you can simulate the robot without any problem. So select that and then click on Apply to change the preferences. And then let's continue and let's start drawing our robot. Now let's start designing our robot. So firstly we are selecting the home orientation. Then we are selecting the XY plane to start drawing our robot. So firstly we are drawing a rectangle to design our robot's base link and its body of the robot. So in there I also shared the initial design actually that I prepared my hand, and we can look at that for the dimensions and other kind of stuff. So the body is 20 centimeters to 30 centimeters. In robotics, the x-axis is generally the movement axis, so we have to be careful to select which axis is the moving axis. So in there, our orientation is towards to the x-axis. So that means we are going to have a robot which has the 200 millimeters width and 30 centimeters length. And let's draw it like that. Now we are moving to the generating the body from extruding this this rectangle by 100 millimeters. And now we have a box. This box is body of our robot. And then we are drawing the other parts like the wheels and other kind of stuff. So first we are selecting the side of our robot. This is the right side of our robot, and then we are selecting a point to draw our wheels. So we are moving 5 centimeters here and 2.5 centimeters here. Before drawing the wheels, we need to draw the joint that we are going to attach our wheels. Okay, so I'm going to add a 30 centimeter diameter joint in there. Actually, it's not a real joint, but we are adding that to differentiate this attachment point with the other side of the body. So by doing that, we are allowed to use our robots and we are allowed to attach the wheel in a correct orientation and in the correct coordinates. So I added that, and I'm also going to add the same thing to the other surface of the robot. Okay, and I'm adding the 30 centimeter diameter joint area, and let's extrude it by 5 millimeters. Okay, it's now I think okay. Then now we are going to generate our wheels. So what are we going to do? We are clicking on there. As you can see, this is the center of this circle, and we are adding this circle as our wheel, and it's going to be 10 centimeter diameter. Then we are clicking on that and we are extruding it. So our wheels are going to be, maybe, let's look at that, 30 millimeters width. I think it's okay, but we have to be careful, because whenever you extrude something from a body, it's make operation join, but we're not going to join body with the wheel. Wheel and body is different components, so we are going to select the new body as operation, so we are going to generate our wheel like that. Now we are going to select the other part of the body, and we are going to do the same thing in there. And now we are extruding the wheel also with 30 millimeter width, and we are also selecting new body in there. So now, as we can see, we have 3 different bodies, and this main body of the robot is the base link, and it's also called in the same name in the gazebo and RViz environments. This is our right wheel, so I'm writing that also, and this is our left wheel. Okay, great. Now we need to move on the caster wheel and the Lidar. Firstly, we are going to move on the caster wheel. So let's click on the bottom of the robot, and we are selecting the point, for example, this point, 1, 2, 3, 4, 5 millimeters, and sorry, 5 centimeters in there, and maybe we are going to have 40 millimeter diameter caster wheel. Okay, and then what are we going to do? We are going to extrude it, and we have to be careful in there, because this body needs to be in a straight, and it needs to be parallel to the surface. So what are we going to do? Actually, this distance between the touching point of the wheel and the body is 25 millimeters, so I'm extruding that for 25 millimeters. I think it seems okay. Then actually to reduce the friction, we need to make it as a ball. And as you can see in the real caster wheels also, they are also using the balls for avoiding from the friction. So when we do that, as we can see, these are in the same plane. But we need to check that also, because a mistake can cause really big problems in the simulation. So I'm moving that thing to the 25 millimeters from starting from the body, and as you can see, it's actually a straight line between the caster wheel touching point and the wheel touching point. Now we need to add some actual last components, like the Lidar and the camera. Actually, on the Lidar is enough to make this robot work with the reinforcement learning. But for the future applications, like we also mentioned about the other applications that we are going to do, so we can also use the camera for that. Anyway, so let's look at the robot from the top, and we are going to add our Lidar in there. So we can select any shape for that, but generally the circle is better, since it's scanning the entire environment with 360 degrees, and I added that, and now I'm extruding it. But I want to mention something. So Lidar is also another link that we are going to add, so it's another component. So firstly, we need to add the place that we are going to hold the lidar. So I'm extruding that for 5 millimeters, and it's actually the operation is join. Then I'm going to add the lidar as another component. So I'm continuing to extrude the lidar component. Maybe this is enough for that, and then I'm selecting the new body. So maybe 30 millimeters are also enough. I think it's fine. Okay, it's a compact robot, I think. So that's okay. And this is the lidar. And then what are we going to add to the to this side of the robot, the front side of the robot? We need to add a camera. You can add it, or maybe you don't have to add it. It depends on you. For many reinforcement learning applications, they are generally using only LiDAR and 2D map. But if you want to do something a bit different, maybe you can use this camera also. And I'm adding my camera to here. And then this is actually the camera holder. As I mentioned in the LiDAR, we have to actually first add the holder. So I'm adding for 1 millimeter holder in here, then I'm adding the real camera. So it's going to be 10 millimeter or something, so it's going to be a new body. So by doing that, we're concluding our robot. Okay, that's nice. So you can see this is our robot. Maybe for that you can select the components for the robot. And you can look at the physical material parts, maybe. In there are other kind of materials. For example, what is that? This is steel. Actually, this is a bad component for our robot, because nobody is going to produce their robot with steel if you're not making a tank or something. So what are we going to use? Actually, we're going to use the plastic, and in there we can use the ABS plastic. And let's actually add it to here. And for example, let's look at its properties. So the density of it is 0.001 grams, nearly like that. We can also change that. Anyway, so let's select all of the components and let's make it from the ABS filament. By doing that, we actually reduce the weight of our robot. So this is an important thing in there. Anyway, so let's continue. So now we added all of the components, and I've forgotten to add the name of it. This is the camera. Anyway, so let's generate components from the bodies. So we are using these components. We cannot use directly bodies for adding links and joins. So let's do that. And as you can see, these are all components in here. So what are we going to do? Firstly, we are going to add some links in there, and joints in there. So we are selecting the joint. And firstly, we are selecting the wheel. For example, we are going to select the right wheel in here. I selected that. Now I'm selecting the body to make it join to this body. And then for the motion, I'm selecting, it's not rigid, it's a revolute joint, so it's going to be turn like that. Okay, so it's okay. For the turning angle, actually turning direction, it's not a problem. We can change it in the Gazebo environment in the URDF file. So we are going to move on that. Then what are we going to do? We are going to add the other joint, the left wheel joint. So I'm doing the same thing. I'm again selecting firstly the wheel, and then I'm opening the basing again, and I'm selecting that. And it's still revolute, and it's okay. Now let's select camera and the Lidar. So we're clicking on the joint function again. Then we are selecting the Lidar, and then we're opening the base link, and we're connecting this to here. And normally lidars are turning, but in there, actually in the simulation, we don't need to turn this thing in there because it's a bit problematic, and we need to use it as a rigid component, as a rigid joint. For the camera, it's same, so we are going to add a rigid component in there also. I'm selecting the camera, then I'm selecting the body of the robot, which we are going to put the camera, and it's also rigid, as you can see. Okay, now we added all joints, and we can see that in here. So for example, this is the, maybe we can name these joints. It's going to be easier to use that in the URDF file. So this is the right wheel joint, and this is going to be the left wheel joint, and this one is the Lidar joint, and this one is the camera joint. Up. Okay. Now we named all of these components, and everything is seemed fine. So this is our robot, so we're going to use that in our simulation. So we made our own robot. If you want, you can add some other kind of details, like maybe you can change the shape of the robot. You can add some curves in there. To make it cooler, or it depends on you, of course. So I'm adding some those kind of things. Wow, there are a lot of options. Okay, but that will be better. Let's add also this one. Okay, that's fine. So this is our robot. Maybe we can add also some detail in there. Like, it seems a bit better by adding these curves. Anyway, this is our robot. Maybe we can add some colors on that, but when we change to the URDF file, it saves every component as a STL file. In the STL files, it's not containing the color, so you have to recolor the entire robot again in the gazebo environment. So I'm not going to add some colors on that. Maybe in the future codes for making robots, converting robots to the URDF file, maybe they're going to add the step files and other kind of files that contains also colors. It's also can be possible for the future works, and it's also supported by the gazebo. But for now, we don't need to color it. And then I'm saving this project as Differential drive, and I'm saving that. So now this is our robot, and after that we need to make it and convert it into the URDF file. I saw that I forgotten to add the name of the camera to the components, so I'm adding the name of the camera in here, and I'm also checking that in here, and it's named camera joint, so there is no problem. Okay, so now I'm saving the document again, and in the utilities part, now we can convert our file into a URDF file. So what are we going to do? Firstly, we are selecting the add-ins button in there, and we are clicking on that menu, and then we are seeing that we have the URDF exporter ROS2, and this is our exporter for the ROS2, applications, and then we are running that. Probably see I made a trial, and that's why there is the differential drive description. I'm deleting that, and now I'm saving my URDF file in the documents directory. Okay, now it's finished to convert it into a URDF file. Now I'm opening the documents file directory. Now in the documents file, as you can see, our description file is generated, and in there are URDF files in here, and we have some meshes in there. Mesh means actually the 3D designs of the robots. So as you can see, all of these components are here that we can use them as our 3D designs in the URDF file. So we are calling them in the files that we are going to use. For example, in the differential drive gazebo file, as you can see, there are some components like right wheel, left wheel, lidar, and its properties. And also for the ROS files, we are using the differential drive exacro in here, in this file. So in there, we are importing all of these meshes in there, and it has their own inertial values, mass values, and other kind of values in here, inertia values. And by doing that, we are using our gazebo simulation and ROS visualization in a very proper way. And this is all about the generating robot and converting the robot in a university robot description file. So thank you for listening our video, and see you in the next videos.